Hello everybody, this is DES2 Unit 7 Advanced Section Views by Todd Frazee. Advanced Section Views. To review what we learned in the basic section views, section views improve visualization on multiple view drawings, facilitate dimension on features obscured in standard orthographic views, and the technique is based on passing an imaginary cutting plane through an object. In the last presentation, the basic section view types we covered were full sections, which section completely through the object, half sections, which go halfway through the object, and broken out sections. Sections a portion of an object that is determined by the designer. In this lecture, we're going to be covering advanced section view types. Revolve sections, which are created by revolving a cross-section view 90 degrees and superimposing the view on a standard orthographic view. Remove sections that don't necessarily follow standard projection rules. Offset sections that have more or one 90-degree bends in the cutting plane line. Assembly sections, which can be orthographic or pictorial section views of an assembly of parts. And auxiliary sections that follow the projection conventions of both section views and auxiliary planes projection. Revolved section views is the first advanced section view that we will cover. A full section passes through the section of the part, and then the cutting plane is centered on the center of the object. Rotation is denoted by arced leader lines on the point of rotation. And the view is superimposed on the orthographic view normal to the cutting plane as shown on the right. It is also optional to use breakout sections to clarify the revolved section view as shown on the example on the right. Now let's go to one of my real life examples of how a revolved section works. We kicked Jack out of the box and stuck in a zucchini, and we projected our top and front views on the glass box. And if we were to look at the top view and you wanted to do revolved, you'd first draw a center line down the length of it and put a cross section in. And then if we are to look at the front view, as if you slice through it would be rotated and projected on the front view. If we unfold our box, we would have a view that looks like this. That is how a revolved section view works. Now let's return to the next advanced section type. Remove section views. The remove section views or revolve section view is not placed according to the conventional rules. So as shown on the right, we have a part that has 3 revolved sections that are placed adjacent to the view. And this is a technique that's typically used when there's not enough room to superimpose the section view on the orthographic view. Aligning these removed sections with the corresponding cutting planes can add clarity though, and is highly suggested. In the example on the right, section A is aligned with the cutting plane lines of section AA, and BB and CC follow suit. Let's return to the kitchen for my zucchini example. So if we took the same revolved view and moved it off of the front view and had it adjacent to the sectioned view, in this case is the top, it would then be called a removed view. In this next example, we have 3 sections through the top view, resulting in 3 removed views. If we take those same 3 removed views and align their center lines with the cross sections that they correspond to, it then becomes what's called an aligned removed view. That wraps up revolved views, and we'll move on to the next advanced section type. Offset section views. They use a cutting plane bent at one or more 90-degree angles. It's intended to pass through important features. So on the right, in the example, the cutting plane has two bends in it so that it can describe the hole pattern, cylindrical feature, and the slot. The changes in direction of the cutting plane line are not represented in the section view, as you can see on the right. Assembly section views. They can be orthographic or pictorial. The example on the right is orthographic, and the section view occurs in what would be the top view. They can be full or half section views. And adjacent parts are crosshatched at different angles to differentiate them from each other. And certain features are not sectioned to help with clarity. The features not sectioned in an assembly section are shafts, bearings, gear teeth, fasteners, ribs, spokes, and lugs, and washers, keys, and pins. If we look at the example on the right, the bolts and the nuts, which are fasteners, are not sectioned in the view. Auxiliary section views. Auxiliary section views follow the projection principles of a section view and auxiliary views. The cutting plane is the plane of projection for the auxiliary view. And you have the option to do a full auxiliary view, as is shown in the example on the right, or a partial auxiliary view, as shown in the second example on the right. Special section view conventions. Ribs, webs, and thin features can be sectioned, leaving thin features unsectioned if parallel to the cutting plane line. Aligned sections, sections that revolve or align features to clarify them. And conventional breaks, breaks in the orthographic view for revolved sections or for shortening the view of elongated parts. Special treatment in section views of ribs, webs, and thin features. For our example, we're going to be using this bracket on the right. It has a flat flange base, cross-shaped ribbed columns with cylindrical bearing type surfaces. So if we were to look at a standard section view of this part, section AA, cutting perpendicular to the columns, shows the web section that looks somewhat like a cross. But in section BB, if we were to do a traditional cross section, would appear like shown on the right. And a convention has been added so that you can allow the display of a web section through a thin area and omit sectioning part of the feature. So the convention is used to leave part of the feature unsectioned to clarify the rib running in the opposite direction. This is only allowed when the cutting plane is parallel to the feature. Aligned sections. Aligned sections use a bent cutting plane line. As shown on the right, we have a cutting line that goes at the top half of the part is normal to a standard orthographic view, and it passes through two holes. In order to describe holes are at 120 degrees, the cutting plane line is bent at 120 degrees to intersect a second series of holes. It's used to revolve or align special features for clarification. So in the example on the right, we'd be clarifying the holes in the bent section of the cutting plane. The view placed normal to the plane aligned with the standard view. So as in the example on the right, if we were normally projecting what you would see without aligning this section view, it would occur on the right because the section of the cutting plane that's normal to the view is pointing left. However, the aligned convention breaks this traditional orthographic view projection of being 90 degrees to the view and projects the profile normal to the cutting plane line and rotates it to align with the view as shown on the right. Conventional breaks. Conventional breaks are used to clarify revolved sections. If you recall from our example of the revolved section, the breakout view was used to clarify that the section view was not a feature shown in the front view of the part. Or for shortening views of elongated parts. As is on the example on the right, the shaft may be longer than the piece of paper that you have to draw it in a reasonable scale. So the view is broken to give a convention so that you can show the true length in a dimension, but display that the part is longer than is shown pictorially. There are several conventions that may be used for different profile types. For rectangular material, typically a squiggly hand-looking drawn break line is drawn for metals and plastics. For materials like wood, a more jagged cutting plane line, breakout line is typically used. And for cylindrical objects, you have the option to use a squiggly line like we do in a typical view, or the S-shaped cut for cylindrical objects as shown in the top examples A and B. That concludes this presentation, and we'll see you on the next one.